Okay, so welcome to today's lesson, wherein we are going to basically look at proton, neutron, and that of electrons. So in high school, I think we have all heard about those words, proton, neutron, and that of electrons. So it's something very easy that you should understand from the station. So we are going to look at them as proton, neutrons, and electrons. So we are going to look at those three subatomic particles. So those three refers to subatomic. They are refers to subatomic particle. And if you look here, you have this word atomic, which comes from atoms. So if you are asked by someone what atoms are or what is an atom, well, you can like basically say that atoms are the building block of matter, what matters are made up of. And we know that matter is anything that has weight and occupies space from our elementary definition, right? So those are the three subatomic particles that make up. They are the proton, neutrons, and that of the electron. Those three makes up the subatomic particle. So before understanding about isotopes, you should first understand the calculations of proton, neutrons, and that of electron, and likewise the mass number calculation as a whole. So we will first start with proton. We say that protons are particles that contain positive charge. So protons are particles that contain positive charges, right? Or positive charge. So if we are discussing about neutron, we say neutrons is a particle that has no charge. It's like neutral, so it has no charge. And when we say electrons, we are discussing particle or species that contain a negative charge, right? So in doing so, we have a formula to solve for proton, neutrons, and electrons. Like I said, they are the three subatomic particles, right? So you can draw the structure of an atom. You can basically draw the structure of an atom, and you can be able to label them where you have the electron being spinning around in the negative charge, and you have neutron and that of proton to have a positive charge right there. So in doing so, we can look at proton. So we can say that proton is equal to the atomic number. So proton is equal to the atomic number. For example, if I tell you that the element carbon has 6 protons, and someone tells you also that the element carbon has 6 as the atomic number, we both are correct because proton is equal to the atomic number. And what about neutron? To find neutron, we say that neutron, which is n now, is equal to the mass number, minus the atomic number. Then what becomes of electron? We can say that electron, which is mostly written as E to this, is equal to atomic number minus the charge, right? So electron is equal to atomic number minus the charge. So in some book or some teacher may tell you that proton is equal to Z, wherein neutron is equal to, you will say A minus Z, and you will say electrons is equal to Z minus the charge. So what Z stands for? What Z stands for? Well, Z stands for the atomic number. So if you can't understand it from this point of view, we say Z, you can use this as saying atomic number. You can just place or just spell it out instead of writing Z. But if you can understand it from this point, you can say that proton is equal to Z, where neutron is equal to A minus Z. So this A stands for the mass number and this Z stands for the atomic number. Okay, so Z also here says that electron is equal to Z minus the charge. What is the charge that we are talking about here? The charge is the number above the species or an element. For instance, let's say like you have nitrogen, maybe we say 3, you have a charge of 3 plus, assuming if it is this, then this becomes the charge right here. If it is 3 plus, this becomes the charge right there. So the charge right here now, you would just say, so nitrogen is element 7, and let's assume that the charge is 3 plus, assuming, so the charge is 3. So you would say that there is the atomic number, which is 7 right here. You're going to say 7 minus the charge is what? Is positive 3. You just write 3 right here. So you minus this, you got your answer right there to be 4. If the charge was negative 3, so it tells that negative times negative give you what? Positive. In a sense that you will say parenthesis open minus 3, negative times this give you what? Positive. So it would be 7 plus 3 gives you 10 in that scenario, right? Okay, so we can move forward in calculating for proton, neutron, and electron. And also, you should remember this formula that says also that mass number, we say mass number, the mass number is equal to the proton plus the neutron. We say proton plus neutron gives us the mass number. So we say proton plus neutron gives us the mass number. So we can write those formulas in the corner right here, for which we are going to look at them to solving our problems as we go along the way. So we can repeat them right here by saying that proton, we can say proton is equal to atomic number, and we can say that neutron is equal to, we say neutron is equal to the mass number minus the atomic number. And we also said that electrons is equal to atomic number minus the charge. And we also say that the mass number is equal to proton plus neutron. So those are the 4 formulas that we should know, or that you should know basically if you have to solve for proton, neutron, or electrons. So you should know those 4 formulas. Okay, so to make that short also, we can say or we say P is equal to Z. And what Z stands for? Z stands for the atomic number. And we can also say that N is equal to A minus Z, where A stands for the mass number and Z stands for the atomic number. And we can say electrons is equal to Z minus the charge. And we can also say that mass number is equal to P plus N, where P stands for proton and N stands for the neutron. So you can learn this formula, you can learn those formulas like this or like this. They all make the same, right? Okay, so let's assume now we were given a problem to find, wherein the problem says, let's say number 1 says found the number of proton neutrons and this electron symbol and electrons of a neutral oxygen which is element 8. So oxygen is element 8. So the problem says that we should find the number of proton, neutron, and electron of a neutral oxygen. We say neutral because in this case here it has no charge, so it becomes a neutral element, right? So the atomic number of oxygen is just 8, as you can see right here. So to find the number of proton, we can say A, or let's say finding the number of proton. To find the number of proton of oxygen, we can say P is equal to atomic number, or P is equal to Z, any one of the choice, right? So we can say P is equal to atomic number. What is the atomic number of oxygen? It's 8, right? It's 8 right here. It's 8. So to find proton is just easy. So we can just place our 8 right here. So this becomes the proton of oxygen. So it tells us that oxygen has 8 protons. So this is the answer. Then we can say finding the number of neutron of the same element oxygen. So we said that neutron, if you look right here to this formula, it said that neutron is equal to the mass number minus the atomic number, or we say N is equal to A minus Z. A is mass number and Z is the atomic number. So you can use any of those formula right there, right? So for me, I say that neutron is equal to the mass number minus atomic number. So what is the mass number of nitrogen? What is the mass number of nitrogen? Do you know the mass number of nitrogen? Do you know the mass number of nitrogen? Is it given in this? Excuse me. Do you know the mass number of oxygen? Do you know the mass number of oxygen? Well, it is not given in this problem. So to know that, you can visit your periodic table, or maybe you should know that offhand. Know the first 20 elements with their atomic number and that of their mass number, if possible, their charges as well. Well, so the mass number of oxygen is 16. And we can prove how 16 came about. We can prove how that 16 came about because look right here, it tells us that the mass number of oxygen here is 16, or it says 15.999. It is seen as 16 right there, right? But we can prove how that 16 actually came about. So watch it and keep going so as we solve along the way. So right here now we say the mass number of oxygen is 16. So we can write 16 right here. We say 16, and this says what this says. Excuse me, what this says right here. How do you find mass number? How do you find the 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 mass number? So this is the neutron that we are finding right here. To find neutron, we say the mass number minus the atomic number. What is the atomic number of oxygen? Is this red is 8, which is the same as proton. So we say 16 minus 8, what it gives us. If you have 16, you minus 8 from there, what it gives you. What is that? If you see 8, right? Because if you say 8 plus 8, it gives us 16. And if you have 16 here, minus one of the 8 from there, it gives us the same 8. So it tells us that the answer for neutron here is going to be 8. It's 8. So neutron here is 8. So it also tells us that oxygen has 8 proton, it has 8 neutron. So what becomes of the electron of oxygen? Well, we can go about solving that. So this is if we are finding for proton, this is B for neutron, this becomes, let's say, C for electrons, finding the number of electrons of oxygen. So to find electron of oxygen, we can visit this formula again that says electron is equal to atomic number minus the charge. Or we can say electron is equal to Z minus the charge, and Z is for the atomic number, right? Hope you get that correctly. And right here we can write right here we can write a formula that says that electrons is equal to atomic number minus the charge. And we know what charge are, or what charges are. So the atomic number of oxygen is 8, right? So place 8 right here. In this compound, or in this problem, it says a neutral compound. So it tells us that it has no charge. So the charge is just 0. So here now, we will say 8 minus 0. So 8 minus that, it gives us the same 8. So it tells us that oxygen has 8 proton, 8 neutron, and 8 electrons, right? And let's assume that the charge of oxygen was given to be minus 2. In that case, it's no longer a neutral element. It becomes ion right there, right? So let's assume that it was minus 2. The charge of it was minus 2. So this minus 2 you see right here, we're going to place this number to this charge right here. Example. So this is actually our answer. So let's assume that we have 8 as atomic number and the charge is minus 2. So we say that atomic number minus the charge. So here now is 8. You put 8 here. You make this minus sign right here. But here now is minus 2. So you put it up by 1 to say, because two charges cannot meet together. It's impossible, right? So right here you do this and you put minus 2. It closes. This is the charge. That is the formula. It's part of this formula. This minus is part of the formula. So here now we can say negative times negative. It gives us a positive. So here it becomes plus. We maintain this 8. Then what is in this area right here? Remember that this sign has been broken away to one positive because of those 2 that was being multiplied. So it's become 2 right here. So it would be 10 if it has a charge of minus 2. So what if the charge here was positive 2? It was positive 2. You could just say, if it was positive 2 here on the charge, so you could just say 8, here is minus right here, is part of the formula. Minus is positive 2. You just put 2 here, it would be 6 as the answer. So isn't that easy? It's very, very easy. So this is how we solve for proton, neutron, and electron. Alright, so after we have learned how to solve for proton, neutron, and electron, we can now move to proving how the mass number of oxygen became 16. How the mass number of oxygen became 16. We can prove that. Do you understand? Yes, we can. So right now we move to this last formula that says mass number. To do that, we can look at this portion. We can write that right here. We want to put how this is thinking about. We are assuming that we don't know the mass number of oxygen any longer. We don't know that, no. But we know the number of proton of oxygen and that of the number of neutron of oxygen. But the mass number, we don't know that. So we can say, we can make that as D. Say we have A, B, C now. We will say D right here. We will say D. So we can say finding the mass number of oxygen. So we say finding the mass number of the same element oxygen, right? So the final mass number, we say mass number is equal to, we can say the mass number is equal to, we said, proton plus neutron gives us mass number, or we say mass number is equal to P plus N. You see that's easier? It's very simple. So right here now we can say P plus N. What is the proton of oxygen? Proton tells us about atomic number. If you have proton, if you have that of atomic number, they are the same. Because we say proton is equal to atomic number. So proton here now is 8. So we write it right here. And what was the neutron that we solved in this problem? We said neutron was 8. So it's 8 right here. We say plus. So we put plus, we put it 8. Is equal to 8 plus 8 give us 16. So it was how the mass number of oxygen becomes 16 on the periodic table, because if you add a proton and the neutron, it gives you the mass number. So it tells that the mass number is made up of proton and that of neutron. So you can look at this perspective right here. This mass number is equal to P plus N and compared to that of, we say, in neutron. You have neutron here, you have neutron here, you have mass number is, you have proton, is here also as the one atomic number. So it's just like you making this the subject right here. You make this the subject of this equation. Isn't that easier? So to do this, this has a negative charge, so it was sent across. It became a positive charge, so it became atomic number plus N. It gives us the mass number. It's very easy. So you can try to find the number of proton, neutron, and electron of those elements right here. I'm putting here. So you can find calcium, you can find neon, and you can find potassium. So try to find them, find their proton, neutron, and electron, and also you should go there by proving how their mass number came to be from the calculation. Thank you for watching this video, and don't forget to keep following my page, subscribe if you have not, and invite others to follow. Let us learn chemistry and see the person of the existence of the universe. So once again, thank you. Have a blessed day.